Imagine sitting around a campfire late at night. The flames slowly start to fade, the bright orange glow turns into soft embers, and eventually the fire looks like it's gone out. All that's left is a quiet pile of ash. But if you've ever gone camping, you know the fire isn't really gone yet. Underneath the ash are glowing coals that can still be incredibly hot. If someone reaches down too soon, they could get very badly burned. That's why most experienced campers pour water over the fire and wait until everything cools before leaving. Nuclear energy works in a surprisingly similar way. Even after nuclear fuel stops producing electricity inside a reactor, it doesn't instantly become safe. The fuel continues to produce heat and radiation for years, which means it must be carefully cooled and stored. Right now in the United States, there are over 90,000 metric tons of spent nuclear fuel being stored, according to the U.S. Nuclear Regulatory Commission. Before preparing the speech, I also conducted a very small survey. Interestingly, every person said they believe nuclear energy could be part of our future energy solution, but many of them also admitted something else. They weren't sure what actually happens to the waste after the electricity is produced. So today, I wanted to explore that question. We'll look at what nuclear waste is, how it's stored today, and what scientists are doing to make storing it safer for the future. When nuclear power plants produce electricity, they rely on fuel made from uranium. Inside the reactor, uranium is split in a process called fission. Fission releases an enormous amount of energy that we turn into electricity. But eventually, the fuel becomes less efficient and has to be removed. Even then, the story isn't really over yet. According to the U.S. Nuclear Regulatory Commission, when nuclear fuel is taken out of a reactor, it's still extremely hot, both physically and radioactively. In fact, it continues to produce heat for years. In other words, just because the power plant isn't using the fuel anymore, doesn't mean the energy in it disappears. Like coals under a dying fire, that energy is still there. It just isn't as visible. Some of the materials inside the nuclear waste also decay very slowly. Scientists measure this using something called a half-life, which is the time it takes for half of the radioactive atoms to break down. For some radioactive elements, this process happens fairly quickly, but others can remain active for hundreds or even thousands of years. Researchers studying long-term nuclear waste disposal have even modeled how certain radioactive materials can slowly move through underground environments if they aren't properly contained. So the challenge isn't really how we can store nuclear waste for a few years. It's managing something that can remain dangerous long after the electricity is made. Because of the lingering heat, the first place spent nuclear fuel goes is into something called a cooling pool. These pools are located at the nuclear power plant. So when the fuel is placed inside them, the water helps carry away the remaining heat. But the water does something else too. It acts as a radioactive shield. According to the federal regulators, spent fuel usually stays in these pools for at least 5 years. It gradually cools down. In a way, it's similar to pouring water on a campfire and wait until the coals stop glowing. Once the fuel is cooled enough, it can be moved into something called dry cask storage. Dry casks are enormous steel and concrete containers designed to safely hold radioactive materials. Some of them which weigh over 100 tons when fully loaded. They're engineered to withstand earthquakes, storms, and even heavy impacts. Engineering studies have shown that these systems are designed to safely contain nuclear waste for decades. Scientists are also developing new ways to monitor the containers. For example, researchers have tested a technology called a muon scanning, which can actually look inside a sealed storage cask without opening it, helping confirm that the fuel inside remains secure. So even though the waste is still contained, there are systems designed to keep that energy safely contained. While current storage systems are considered safe, scientists are still working on better long-term solutions. One of the most promising ideas is storing nuclear waste deep underground in something called a geological repository. These facilities would place waste hundreds of meters below the surface inside stable rock formations. The surrounding rocks act as a natural barrier, helping prevent radioactive materials from reaching groundwater or the environment. Researchers studying underground disposal systems have created models showing that these geological barriers could also safely isolate nuclear waste for extremely long periods of time. At the same time, engineers are developing new technology to better monitor stored waste. Recent studies have used machine learning models to predict temperature changes inside storage systems, allowing scientists to detect potential issues long before they become serious. These advances help make sure that even as time passes, nuclear waste storage remains carefully controlled and monitored. Now think back to that campfire game. At first, the flames are bright and powerful. They give off heat, light, and energy. But eventually, the fire burns down. All that remains is a quiet layer of ash. Even then, the coals underneath can still be hot enough to cause harm. That's why responsible campers don't just walk away. They take the time to cool the fire and make sure it's safe before leaving. Nuclear energy works in a very similar way. Even after the electricity is produced, the remaining fuel still holds energy that must be carefully managed. Today, we looked at the nuclear waste is, how it's stored in cooling pools and dry casks, and how scientists are working towards safer long-term storage solutions. Just like putting out a campfire protects the next group of campers who arrive, safely managing nuclear waste helps protect the people who will come after us. Because long after the flames are gone, we still have a responsibility to make sure the coals are safe.